Hi, so for today we are going to continue our part 3 of the 1001 solved integrals. So we are already on the part 3, and for today's video we are going to solve some definite integrals, simple definite integrals from numbers 21 to 30. So the numbers 1 to 10 is our part 1, 11 to 20 is the part 2, and here we are for the part 3. So for the definite integral, the same rule applies when we are dealing with the indefinite integral. So what's the difference between the definite integral and indefinite integral is that we already have what we call the upper limit and the lower limit in the integral. So, and the answer, if the upper limit and the lower limit are both constant, the answer will be a constant value or a value, okay, a numerical value rather than an expression of a function f of x. So if we are going to evaluate this, the same rule applies. We can factor out 3 outside of the integral sign, and then we have x squared dx here evaluated from 0 to 2. So we can have 3, and then we have x cubed all over 3 as the integral of x squared, so evaluated from 0 to 2. So we can factor out 1/3 or 1/3 outside of that integral, evaluation of integral, so that we have x cubed all over x cubed evaluated from 0 to 2. So we can always do that. So we can see that this one would cancel actually, and then we have 2 cubed minus 0 cubed. So eventually we have 8 as our value. So it's better to get rid of the 1/3, okay? Because it would actually, we can always factor out 1/3, because if we evaluate this x cubed all over 3, it would make our computation more complicated. So we can factor it out before we distribute the upper limit and the lower limit. So for number 22, we are going to evaluate the integral of x plus 4. Then we have dx evaluated from 1 to 3. So the same rule applies. We can separate this because we have a summation. Okay, and then we have x dx plus we have the integral of 4 dx evaluated from 1 to 3. Okay, so in doing this, we would be simply making our integral much easier to solve rather than integrate it and then apply the limits. So we have x squared all over 2, okay, evaluated from 1 to 3, plus we have 4 integral of dx, right, evaluated from 1 to 3. So let me just rewrite this. We have x squared all over 2 evaluated from 1 to 3 plus 4 multiplied by the integral of dx is simply x evaluated from 1 to 3. So as I have said, we have 1/2 here. We can factor it out, okay? And then we have x squared, okay, evaluated from 1 to 3, and then we have 4 times x evaluated from 1 to 3. So let's do the limits, okay? Let's apply the limits, the upper limit minus the lower limit. So we have 1/2. That would be 3 squared, okay, minus 1 squared, plus we have 4. Upper limit is 3 minus 1. Okay. So evaluate this. We have 1/2. We have 9 minus 1. We have 8. Plus we have 4. 3 minus 1 is 2. So we have 8 all over 2 is 4. Then we have 4 plus 8. Then we have 12 as our answer. Okay. So that's how you simply evaluate, okay, the definite integral. So you can also use the process of which you will not be separating this in terms of summation, but some of the students or most of the students are actually confused when doing that integral. So my advice is to still apply the what we have learned on the properties of the integral in the indefinite integral. Okay, so how about this? So first, we are going to distribute 2x here, okay, such that this becomes the integral of 2x squared minus 2x, okay, then dx evaluated from 0 to 1. So you can also do that, okay. so that we can now separate the integral. So we have integral of 2x squared dx minus integral of 2x dx evaluated both from 0 to 1. So I can factor out 2 outside of the integral sign because that's the property of integral. Okay, minus 2 again also here. Then we have x dx here. So we evaluate the integrals. So we have x cubed all over 3 from 0 to 1 minus 2 times we have the x squared all over 2 from 0 to 1. So we can factor out 1/3. So we have 2 times 1/3. And we have left x cubed evaluated from 0 to 1. Let me just rewrite it as bracket so that you will not be confused. So you have x cubed is from 0 to 1. Then we have minus 2 multiplied by 1/2. I can factor out 1/2. Then we have x squared evaluate from 0 to 1. So we have 2/3. Then distribute the limit. So we have 1 cube minus 0 cube. Okay, we know that this cancels so that we have 1 squared minus 0 squared. Okay, so what will happen is that we have 2/3 times 1 cube is 1. 0 cube is still 0. So we have 1 minus 1 squared is what? 1 squared is 1. Okay, so 0 squared is 0. So we have 2/3. Technically, we have 2/3 minus 1. Okay, so if we are going to simplify that, we have 2 minus 3 all over 3. So that is negative 1/3. Okay? So that would be our answer. Okay, so negative 1/3 is our answer. So number 4, we have the integral of x squared plus 2x plus 1 dx evaluated from 1 to 2. Not number 4, I mean. So this is number 24. Okay, so we have to number it. So same rule applies. We can separate this since this is summation. We can write it as this. Then we have plus dx. Okay, 1 dx or simply dx. So get the integral for every term, x cubed all over 3, evaluated from 1 to 2, plus I can factor out 2 outside of the integral and evaluate x dx. So that would be x squared all over 2, evaluated from 1 to 2. And then the integral of dx simply is x, evaluated from 1 to 2. So we are going to simply uh, factor out 1/3 again. Okay, and then we have x cubed evaluated from 1 to 2, and then we have to factor 1/2 here. So we have x squared evaluated from 1 to 2 plus we have x evaluated from 1 to 2. So we have 1/3, then we have 2 cubed minus 1 cubed. This would cancel. So we are left with plus 2 squared minus 1 squared. Then we have 2 minus 1. Okay? So let me just replace this with simple parentheses because we have already evaluated the limit. So you have 1/3. 2 cubed is 8. So 1 cubed is 1. So 8 minus 1 would become 7. Plus we have 2 squared is 4. Okay, 1 squared is 1. So we have 4 minus 1, that is 3. And then 2 minus 1 would be 1. Okay. So we have 7 all over 3 plus 4. So we have 7 plus 12 all over 3. So you just cross multiply 3 times 4 is 12. Then you add it with 7. So that's how you do it. So 12 plus 7 is 19 all over 3. So that would be the answer for our definite integral. Okay? So 19 all over 3. So it's very easy, right? It's very easy. Okay, by applying the properties of indefinite integral, you should be able to easily solve the definite integral. So how about this? Same process. We have integral of 2x dx plus the integral from 1 to 5 of the 3dx. So I can factor out 2 outside of the integral sign. So because that's a constant, so we have factor again 3 outside of the integral sign, then get the integral. So integrate x dx would be simply x squared all over 2 again, evaluated from 1 to 5. Then we have 3. Integral of dx is simply x from 1 to 5. So I can factor out 1/2 here. Okay, and then we have to evaluate x squared from 1 to 5 plus 3x, okay, evaluated from 1 to 5. So this 2 times 1/2 would simply canceled out, so that we have left, evaluating the integral will be 5 squared minus 1 squared plus 3, 5 minus 1. So 5 squared is 25 minus 1 is 24 plus 3 times 4. Okay, so 24 plus 12 is 36. Okay, 4 times 3 is 12. So that's 36. For number 26, we have to evaluate the integral of x squared minus 4x dx. Same process that we're going to do. We can factor out or rewrite this as the properties of integral like this. Okay? So factoring out the constant, so we have this. Okay? And then integrate. So we have x cubed all over 3 evaluated from 2 to 4 minus 4. Integral of x would be x squared all over 2 evaluated from 2 to 4. So factor out 1/3 outside. Then we have x cubed from 2 to 4. Factor out 1/2 outside. So we have x squared from 2 to 4. Evaluated from 2 to 4. We can always do that. Okay. So now we have 1/3. Then we have 4 cubed. Okay. So this would be 4 cubed minus 2 cubed. 4 divided by 2 is 2. So minus 2. Then we have 4 squared minus 2 squared. So 4 cubed, 4 times 4, 16 times 4 is 64. 16 times 4 is 64, yes. 64 minus 8 minus 2. 4 squared is 16 minus 4. So 1/3, 64 minus 8, that is 56. Okay, 56. So is it divisible? So minus 2, 16 minus 4 is 12. Okay, so 56 all over 3, is it divisible by 3? So I think it's not. Okay, so we have 56 all over 3 minus 24. So that is simply 56 minus 24 times 3 all over 3. Okay, so 24 times 3 is 12, 1, 6, 72. So we have 56 minus 72 all over 3. And 56 minus 72, let's try. We have 6, and then we have 6, 16. Okay? So 16, 62. Is it correct? Yeah, it's, since 56 minus 72, it's negative 16. Okay? So negative 16 all over 3. So that will be our answer for it. So let's go now for number 27, I think. So the integral of the x cube, it's very easy. Dx from 0 to 2. So, and that is x raised to 4 all over 4 evaluated from 0 to 2. So we can factor out 1/4, then evaluate x raised to 4 from 0 to 2. So that must be 1/4 of 2 raised to 4 minus 0 raised to 4. So 2 raised to 4, 2 times 2 is 4, times 2 is 8, 5 times 2 is 16. So we have 16 all over 4, and then we have 16 all over 4 would be 4. For 28, we have to have the integral of 3x x plus 2 dx evaluated from 1 to 4. So first things first is we can distribute. We have 3x squared plus 6x. Then we have dx here. And then by properties of integral, we can rewrite it as 3 integral of x squared dx plus 6 integral of x dx, both evaluated from 1 to 4. So take note that I already factored out the constants. So we have 3, we have x cubed all over 3, then evaluated from 1 to 4, plus we have 6, okay? Then we have x squared all over 2 evaluated from 1 to 4. So we have to factor out 1/3 so that we can easily evaluate the integral. Factor out 1/2 on the second term. So we have x squared evaluated from 1 to 4. So this canceled. So 6 all over 2 would be 3. So we have 4 cubed minus 1 cubed plus we have 3. Then we have 4 squared minus 1 squared. 4 cubed, 4 times 4, 16 times 4, 64 minus 1. Plus we have 3 times 4 squared is 16. Minus 1 squared is 15. Okay? So we have 63 plus 45. Okay? Because 3 times 15 is 45. So we have what? We have 8, 108. Okay? So 108. So 108 as our answer here. So for number 29, let us try to solve some problem. Okay. So let's try some again 29. Last two problems. So you have the integral of 3x squared minus 2x plus 1. We have dx. So getting the integral of that, I think, do we have a problem like that? So not yet, we don't have. So you have 3x squared minus 2x plus 1. So by properties of integral, I can rewrite it as x squared dx from 1 to 2 minus 2 integral of x dx from 1 to 2, then plus integral of dx evaluated from 1 to 2. So evaluate, so we have x cubed all over 3 from 1 to 2 minus 2, then we have x squared all over 2, that's the integral of x, evaluated from 1 to 2, plus we have x, evaluated from 1 to 2. So we can factor out 1/3, so this cancels. So we have x cubed from 1 to 2, minus 2, factor out 1/2, so this cancel. So we have x squared evaluated from 1 to 2, plus we have x evaluated from 1 to 2. So substitute or evaluate the upper limit minus the lower limit. So we have 2 cubed minus 1 cubed minus we have 2 squared minus 1 squared plus we have 2 minus 1. 2 cubed is 8 minus 1, that's 7 minus we have 4 minus 1, it's 3. Then plus we have 1. So 7 minus 3 plus 1. 7 minus 3 is 4 plus 1 is 5. Okay. So that's the answer. And lastly, for our number 30 of the 1001 solved integrals, so we have integral of x multiplied by 2 minus square root of x. Evaluated from, I think that's 1 to 4. Okay. So we are going to distribute this, okay, so that we can evaluate the integral. So we have 2x dx 1 to 4. Then we have minus the integral from 1 to 4 of x multiplied by negative square root of x dx. Okay? So technically, using properties of integral, again, we can factor out 2 outside of the integral. So we have x dx here. So technically, the exponent of x here is 1. So the exponent of square root of x here is 1/2. Okay? So would not be negative because we already have the minus sign here. So that's the reason why we don't have the negative here. So we have x raised to 1 and then multiplied by x raised to 1/2 dx. So if they have the same base, okay, so we can add them up. X raised to 1 multiplied by x raised to 1/2 is same with x raised to 1 plus 1/2. Okay, so that we will do here. So we have x raised to 1 plus 1/2 since they are multiplied. So 1 plus 1/2 is 1.5 or 3/2. Okay, and then we have dx in here evaluated from 1 to 4. So we have 2. We have x squared all over 2 evaluated from 1 to 4. And then we have minus. Okay, that x raised to 3/2. So we will be adding 1. So that would become 3 plus 2 all over 2. So that is 5/2. So that would become x raised to 5/2 all over 5/2 evaluated from 1 to 4. So factor out the constants first. Okay, so that would be 2 times 1/2. That's cancelled out. So that we have x squared from 1 to 4. Minus, getting the reciprocal of this and factoring it outside, this becomes 2/5 of the x raised to 5 all over 2 evaluated from 1 to 4. So this becomes 4 squared minus 1 squared minus 2/5. And then we have 4 raised to 5/2 minus 1 raised to 5/2. Okay? So that would be the definite integral. So that would be 16 minus 1, it's 15 minus 2/5. 4 raised to 5/2 can be actually rewritten as 4 raised to 5 square root of 4 raised to 5. Then we have minus square root of 1 raised to 5. Okay? So if we do that, 4 raised to 5, 4 times 4, 16, times 4 is 64, times 4, 64 times 4 would be 256. So that would be square root of 256 minus, what's the square root of 1 raised to 5? That is 1 raised to 5 is 1. The square root of 1 is still 1. So the square root of 256, sorry, this would not be 256 because we already have 4 raised to 4. Okay? So this must be times 4. So that's 1024. 256 times 4, that's 1024. The square root of 1024. So we have 15 minus 2 all over 5. The square root of 1024 is 32. Okay, 1024, it's 32 minus 1. So we have 15 minus 2/5. 32 minus 1 is 31. Okay. So we have 15 minus 31 times 2 is 62 all over 5. So evaluate that. That would become 15 times 5 minus 62 all over 5. 15 times 5 is, if I'm not mistaken, that's 75 minus 62 all over 5. So 75 minus 62 would be 13. So that would be 13 all over 5. So that would be our answer for today's problem. Okay, or in this problem, 13 all over 5. So we have 4 raised to 5 equals to 1024. My bad for writing it as 256. It's only 4 raised to 4. I forgot we have 4 raised to 5. So that's square root of 1024. So we have an answer of 13 all over 5 for our problem here. Okay? So I hope you enjoyed our series of 1001 integrals, solve integrals. So we have a long way to go. So we only solved 30 so far problems here. So if you are new to my channel, please kindly subscribe to my channel and share it with your friends so that you will enjoy learning calculus or integral calculus in this lesson. So thank you so much, guys, and See you again on the next video about this. So, thank you and God bless.